Alright, today we are moving from water on the surface of Earth to groundwater. And the first thing to talk about when we talk about groundwater is just the distribution and movement. Where is it located and how does it move through rock layers in the ground? The majority of groundwater does soak into what we call the water table, which we'll see in just a minute. But it's important to note that there is some water held near the surface through what we call adhesion. And adhesion is just the stickiness of water. Okay, if you take a cup of water, you splash it on the wall, does every drop of water flow straight to the ground? No, we know that these droplets form on the wall, they stuck to the wall, and that stickiness or adhesion means that some water is held near the surface around, soil, sediment particles, and that's important for things to grow, like the grass with very short roots. They depend on this water held near the surface by adhesion. But the majority of the water soaks deeper into the ground to what we call the zone of saturation. The zone of saturation just means that the soil is saturated with water. The pore space, the space between sediment, is completely full of water. So most water does soak down into the zone of saturation. Above the zone of saturation, we have the zone of aeration. So this is where the pore space is just full of air. There is a little bit of water, again, through adhesion, sticking to these sediments, but most of the water is down in the zone of saturation, meaning the zone of aeration, that space is full of air. And what separates the zone of aeration and the zone of saturation is the water table. Okay, that's something that you've probably talked about before, but it's really just that fine line between the zone of saturation and the zone of aeration. When we talk about the movement of groundwater, there's really two important terms that we need to understand the movement of groundwater. The first term is porosity. And porosity is just simply the amount of space between sediment. If you think about two different size pieces of sediment, let's say sand and gravel, and if you really think and look closely at sand and gravel and how those sediment pieces rest on one another, and really more important, the space they make when they lean on each other, gravel has much bigger pore space. They have a much bigger space between sediments when you just have a bucket full of gravel. The sand, on the other hand, being a much smaller sediment, has a very small pore space, a very small space between these pieces of sand grains. And porosity is important because porosity really determines our next term, which is permeability. And permeability is just the ability to release a fluid, or really you can think of water flowing through a rock layer. If it's permeable, water can make its way through. If it's impermeable, water cannot travel through it. And if we think back to our bucket of gravel, maybe a bucket of sand, if you pour a glass of water in a bucket of gravel, and a glass of water in a bucket of sand, which of those two sediment sizes would allow the water to travel to the bottom of the bucket the fastest? And you guessed it, it's going to be the gravel with those big pore spaces. So porosity really will determine permeability. Porosity and permeability are important when we talk about aquifers. An aquifer is a rock layer that is both permeable and porous. It contains water, and the water can actually travel through that rock layer. These are important to identify because, we like to drink water. All of our wells are drilled down into aquifers. And there's two different types of aquifers. There's an unconfined aquifer and a confined aquifer. An unconfined aquifer is one that has an impermeable rock layer below it, but it's open to the surface on top. And this is not quite as safe as a confined aquifer in terms of contamination. An unconfined aquifer, anything that spills on the surface of Earth could soak down and contaminate your drinking water. Unlike a confined aquifer that has impermeable rock layers on top and on bottom, it's sandwiched, it's safe. It's a lot less likely to have contamination enter into a confined aquifer. Whenever you have the water table intersecting the surface of Earth, you get something called a spring. A spring is when groundwater becomes surface water, and it's really that intersection between the water table and the surface of Earth. A special type of spring is a hot spring. I'm not sure how many of you have had the chance to visit hot springs, but they're really, really awesome. A hot spring is just when the water is relatively warmer than it normally is. It only has to be around 6 to 9 degrees Celsius warmer than what we call mean annual air temperature. So just the average temperature of a location throughout the entire year, which right here in Hudsonville, it's 56 degrees. So if we wanted to talk about a hot spring here in Hudsonville, it might only have to be 75 degrees to be considered a hot spring. And I don't know about you, but like when I jump in a pool, I expect it to be 80 or 85. So 75 wouldn't even feel very warm, but technically that would be a hot spring here in Hudsonville. The source of heat is usually some nearby magma, and that heats up the rock layers, and it heats up the water flowing through those rock layers. That's what can produce these hot springs. A really special type of spring is called a geyser. And a geyser is this intermittent eruption of steam. To have a geyser, you first have to have caves, and those caves have to fill up with water. And you have to have caves and water and hot rock layers. Again, there needs to be some source of nearby heat, probably magma. And what happens is the water in these caves is superheated, several times the boiling temperature of water. But because there's so much water pressing down on these caves, there's a lot of pressure, meaning it can get to really high temperatures without turning into steam. But as soon as some of the water from these caves spills out onto the surface, it removes the pressure and it allows all of this superheated water to instantly flash into steam and turn into a gas and expand and look for a way out, which the only way out is up to the surface and a geyser eruption. And then after the eruption, the caves, they slowly fill back up with groundwater, which is superheated, and the process just happens again and again. One of the most famous examples of geysers is Old Faithful and Yellowstone National Park. It's not the best geyser in the park anymore, and it's not actually that faithful, which means time. It used to be very regular and how often it would erupt. But because of some shifting rock layers, because of some earthquakes, Old Faithful is not very faithful at all anymore. Okay, that's it for today, so make sure you take good notes and make sure we're asking questions. Thanks.